Okay, now going back to the problem we just looked at, x cubed plus x squared minus 3x minus 3 equals 0, and we found that the possible solutions were 1, -1, 3, and -3. Now I want to know if any of those four possible solutions are actual solutions. There's a chance all three of our solutions are in that list right there, but we need to check. One way would be to take each one of these four possible solutions and plug them into the value of x. If it simplifies to 0, then it ends up being an actual solution. A faster way to do that, or a quicker way, now again, 4 wouldn't be that hard, probably shouldn't take too much time, but if you do have a big list, a faster way would be using your calculator. Go to y equals and plug in the equation. I already have it plugged in there. X cubed plus x squared minus 3x minus 3. And I'm going to use the table function. Now, I suggest whenever you use the table function to go to the table set here. If you hit second window, this is going to let us do two things. It's going to let us decide where our table is going to start at. In this case, my table would have started at 22.5. We need to check 1, -1, 3, and -3. So 22.5 is nowhere close to that. It also is on right here is where it is what the table is going to count by. Okay, it's the change of the table. It was set at 0.5. All of our values are integers, so we're not set it at 1. So I'm going to start at 0, and I'm going to count by 1. Now, when you go to second table now, you're going to start at 0, and you can see we're counting by 1s. So we need to go through and check 1, -1, 3, -3. So right away, 1 is -4. That's not a solution. 3 is 24. That's not a solution. -1 gives us 0. That means since it's y equals 0, if you would have plugged in -1 to that equation, you would have simplified to 0. So -1 is one of our actual solutions. Checking -3 gives us -12, so that's not a solution. But we did get 1. We got that -1 was an actual solution. Okay, so now we'd be able to move on from there knowing at least one of our three solutions. Doing another example, here we have 3x cubed minus x squared minus 15x plus 5 equals 0. Now I already did the work. The possible solutions are 1, -1, 5, -5, 1/3, -1/3, 5/3, and -5/3. Now, this is a little different. The reason I picked this one is because some of the possible solutions are in fraction form. Since they're in fraction form, counting by 1s won't work. Counting by 1s won't give us that 1/3, -1/3, 5, and -5/3. So I'm going to go back to my calculator now. I'm going to go back to y equals and plug in my new equation. So give me a second to do that. Okay, I'm going to read it real quick. 3x cubed minus x squared minus 15x plus 5. Okay, I'm going to go to second table set. I'm going to start at 0 again. Now this time instead of 1, I'm going to plug in 1/3. Okay, so now I know I'm going to count by 1/3. I'm going to be able to see the 1/3, -1/3, 5/3, and -5/3. Okay, so when I go to second table now, I'm starting at 0 and right there's a 0. 1/3, or in this case it's 0.333. So you do need to know how the decimal and fraction conversions to help a little bit. But you can see that 0 means that 1/3 is an actual solution. There's 1. Okay, we can go to 5/3 would be 2.67. That's not going to be a solution. We do need to scroll down to 5. So it takes a little longer to get from one spot to the next. 5 gives us 280, so that's not a solution. So let me go check my negative values real quick. Okay, -1's a no, -1/3 is a no. -5/3 is a no, and getting up to -5. -5 is a no. So the only actual solution in this case, again, we only had one of them. Keep going with, there it is, 1/3. 1/3 gave us 0, so 1/3 would be our actual solution. Right? Now I can't say there will be any actual solutions in those possible rational solutions. If they all end up being either complex or irrational numbers, you won't be able to find them in this method. But this is one way of solving these equations that are a little uglier than the things that we have been dealing with before. Okay, so there's a shortcut on the calculator, and the last part's on how you would complete this problem then.